All right, so in order for us to solve a quadratic, we can do that by graphing, the first way we learned. Two, we could try factoring. That's always quick, but not everything is factorable. We found that the quadratic formula works on everything. Then if you really want to know about completing the square, here we go. But before we learn how to complete the square, there's a couple of things that we need to realize first. And that is, when you have an equation such as this, x minus 2 quantity squared is equal to 9. Well, what kind of number is 9? Let's look at number 2. What kind of number is 49? Let's look at number 3. What do we have with 144? What kinds of numbers are these? If you're thinking perfect squares, you're absolutely right. These are perfect squares. Look at what we have on the left side of the equation. We have the parentheses squared. We have a parentheses squared, and we have a parentheses squared. This means they are also perfect squares. Here's what we're going to do. To solve these equations, we're merely going to take the square roots of both sides. Because if you're to take the square root of x minus 2 quantity squared, the square root sign and the squared sign cancel each other out, and you're left with x minus 2. That'll be equal to, now we have to take the square root of the right side, and what is the square root of 9? Well, you're half right. It's not just 3, it's plus or minus 3. Remember, we have to have, when you're taking the square root of a number in an equation, you've got to use the positive and the negative. So at this point, you're going to write two different equations. X minus 2 is equal to the positive 3, and the x minus 2 is equal to the negative 3. When we solve this first one, we get x equals 5. Solving the second one, we get x equals negative 1. So we have 5 and negative 1. Going to do the same thing in number 2. I have a perfect square on the left side. I have a perfect square on the right side. And I can take the square roots of both sides. Because when I take the square root of something squared, the square root and the squared cancel each other out. You're left with x plus 3 is equal to, right, plus or minus 7. So write two equations. X plus 3 is equal to 7. X plus 3 is equal to negative 7. And solve each of these. We get x is equal to 4. X is equal to negative 10. So we have 4 and negative 10. So let's look at number 3. Taking the square root of both sides, I have 2x minus 3 is equal to plus or minus 12. So we write two equations. 2x minus 3 is equal to 12. 2x minus 3 is equal to negative 12, and solve each equation. So we're going to add 3 to both sides. We get 2x is equal to 15. X is equal to 7.5. Add 3 to the right side. We get 2x is equal to negative 9. X is equal to negative 4.5. So we have our two answers, 7 and 1/2 and negative 4 and 1/2. Make sense so far? Okay, good. Let's go on to the next set of problems and see what we're doing there. All right, numbers 4, 5, and 6. We want to find the values of b. So we want to know what this number is going to be right here. What's b that will make each expression a perfect square? Well, what do we mean by a perfect square? Well, a perfect square is when you multiply two of the same thing and you get the original problem. In other words, if I were to factor a problem and get the answer x plus 9, wouldn't we have the x times x, x squared, 9 times 9, 81. We get plus 9x, and we'd have x squared plus 18x plus 81. Well, what's b equal to? 18. So that's what b would have to be in order for this to be a perfect square, because a perfect square is when you multiply two things together and you get that original problem. So if 18 were b, we would have a perfect, it's called a perfect square trinomial. Let's look at number 5. If I were to factor this, I would end up with two sets of parentheses, right? And x times x is the x squared, and 11 times 11 is the 121, right? Put a couple of plus signs in here, and what would b have to be equal to? Well, 11x plus 11x is 22x. We'd have the 11 times 11 for the 121, right? The x times the x for the x squared. So x squared plus 22x plus 121, this is called a perfect square trinomial. And b would have to be equal to 22. Let's look at number 6. Maybe not quite so easy. Let's see now. I would have to have x and x. Well, what's the square root of 1/4? Well, we'd have to have 1/2 and 1/2. Notice that's what we did for the first two problems. The square root of this number goes here and here. The square root of this number goes here and here. So the square root of 1/4 would be 1/2, wouldn't it? Put in a couple plus signs. Because x times x would give me the x squared. 1/2 times 1/2 is the 1/4. What would b have to be equal to? Well, 1/2 x plus 1/2 x. Wouldn't that give you 1x? So in this case, b would have to be equal to 1. Well, these are perfect square trinomials, and that's what we need to have when we're talking about completing the square. All right, so let's dive in and see what it takes in order to complete the square. We're going to take x squared minus 6x minus 80 equals 0, and we are going to, so we're going to solve this equation. It's a quadratic equation, right? X squared. We are going to solve this quadratic equation by completing the square. Number 1, step A, make sure a is equal to 1. Well, what do we have here? We have a is equal to 1, right? Perfect. So we have x squared minus 6x minus 80 is equal to 0. Now, the x squared plus bx, we want it by itself. In other words, we need to take c and get it to the other side of the equal sign. How are we going to do that? We're going to add 80 to both sides. So we have x squared minus 6x equals 80. Now, here's the next step. We're going to take b times 1/2. Here's the formula. Just take this formula, 1/2 of b, and square it. Well, 1/2 times what? -6. And we're going to square that. What do you get? Well, what's half of -6? -3. What's -3 squared? +9. We're going to take that number and add it to both sides of this equation. So I have my x squared minus 6x equals 80, and I'm going to add this 9 to both sides. Now, I'm going to factor the left side. It's going to take two sets of parentheses. I need x times x to get my x squared. I need 3 times 3 to get 9. I need two minus signs, so we have x minus 3 times x minus 3. That's we made this a perfect square trinomial by taking half of b and squaring it. Well, I factored the left side. Now I need to simplify the right side. What's 80 plus 9? Got 89. And now I need to take the square roots of both sides. So if I were to take the square root of x minus 3 squared, I would get x minus 3. If I were to take the square root of 89, I would get 9.4. So in my equation, I'm going to put plus or minus 9.4. At this point, I write two different equations. X minus 3 is equal to 9.4, and x minus 3 is equal to negative 9.4. And I simply solve both equations. Add 3 to both sides, and I get 12.4. Add 3 to both sides, I get negative 6.4. And that's how you solve by completing the square. Now, I'll tell you what, if you want to try this one on your own, you're going to pause the video for a couple of minutes, but do this before you do it, before you pause this. Let's split this in half. And you try it here, and if we make any mistakes, then we'll show you how to do it here. But you go ahead, if you're ready, if you think you're ready to do this, go ahead and try it and see if you can come up with the correct answer. Otherwise, I'm just going to keep plugging away here. All right, I need to make sure I have a is equal to 1. We have that. Rewrite the equation. X squared minus 4x is equal to 9. Now, if you already have this over here, no problem. Just leave it. But if you've made any mistakes along the way, let's fix those in the right column. So I need to get the x squared plus bx by itself. And we already have that. See how c is on the right side? That number 9 is already over there. So leave it over there. We don't want 0. See, all the other problems that we've had 0 on the right side, right? This is the only exception. We don't want 0 on the right side. This is the only time when we're going to want c on the right side of the equation. So we have that, so don't mess with it, right? Now, I need to take negative 4b and divide it by 2, half of b, and then I'm going to square it. Well, what's negative 4 divided by 2? It's negative 2 squared, positive 4. I'm going to add this number to both sides of this equation. X squared minus 4x plus 4 is equal to 9 plus 4. Factor the left side. It's going to take two sets of parentheses, x times x. I need 2 times 2. It's always going to be the square root of that number. We put this number here because it's a perfect square. The square root of it is 2, so we put 2 here and 2 here. We need this sign on both of them, so minus and minus. Take the square root of both sides. So put the square root sign over everything. The square root of something squared is just that something, so we're going to have x minus 2. It'll be equal to the square root of 13, which is 3.6. So we're going to put plus or minus 3.6. At this point, we're going to write two different equations. X minus 2 is equal to 3.6, and x minus 2 is equal to negative 3.6. And just solve each equation. We're going to add 2 to both sides, and we get 5.6. We're going to add 2 to both sides here and get negative 1.6. And that's all there is to it. Let's see what happens in the next problem. All right, in number 9, we have 3x squared plus 30x minus 12 is equal to 0. And step A says, make sure that A is equal to 1. Well, A is not equal to 1, is it? So what can I do to it? Forget about this stuff over here. What can I do to this to make sure A is equal to 1? Well, how about if I divide by 3? And if I divide that by 3, I have to divide everything by 3. I don't care what these guys end up being. In this case, they come out to be integers. But if they don't, big deal. I don't care. Follow the steps. Make sure A is equal to 1. All right, so when we divide that, we get x squared. Divide this, we get plus 10x. Divide this and we get minus 4 is equal to 0. Done. Now we don't need the 3 outside the print. We're not factoring out the 3. I just want to make sure that a is equal to 1, so I'm just dividing everything by 3 to make sure that a is equal to 1. Now, I need to get the x squared plus bx by itself, meaning I need to add 4 to both sides. So I'm going to have x squared plus 10x is equal to 4. What's b equal to? 10, isn't it? Well, take 10 and divide it by 2, and then we're going to square it. That's the rule. It doesn't matter what the rule is, follow it. If it says take b and divide it by 2, do that. And if it says to square it and get 25, then do that. It's the rule. It's the step that you follow. Take half of b and square it. Now, once you have that number, add it to both sides of the equation. So we're going to have x squared plus 10x plus 25 is equal to 4 plus 25. Factor the left side. 2 sets of parentheses. X here and x here. The square root of 25, that's the reason why we make this a perfect square trinomial, is to make, all we're going to do is be taking the square root of that, and we get 5. Throw in a couple of plus signs, and that'll be equal to 29. Take the square root of both sides. Don't forget the plus and minus. The x plus 5, x plus 5. The square root of something squared is just the thing. So we get x plus 5 is equal to, now, what's the square root of 29? What did you get when you round this off to the nearest tenth? Is it 5.39? Is it 5.3? 5.4? Is it just 5? Is it just 6? What do we have here? Rounding this off to the nearest tenth would be 5.4. So we're going to have x plus 5 is equal to plus or minus 5.4. At this point, write two different equations. X plus 5 is equal to 5.4, and x plus 5 is equal to negative 5.4. Subtracting 5 from both sides, you get x is equal to 0.4, and when you subtract 5 from here, you get negative 10.4. So 0.4 and negative 10.4 are your two answers. Well, good luck on your test. Hope things work out. If you have any questions, come see me after school sometime and we'll discuss this. But in the meantime, good luck. We'll talk to you next time.